Hi everyone, sorry I can't be in class with you today, but we're going to move right along and learn about ionic compounds. So, ions. We've learned that atoms gain or lose electrons to become ions. A quick review of this concept. I'm going to draw a Bohr diagram for the element beryllium. So let's get my periodic table. I see that beryllium has 4 protons and a mass number of 9 minus 4 is 5 neutrons. Now you don't need to copy this part down, I just want you to listen. So if it has 4 protons, I know that it also has 1, 2, 3, 4 electrons. Remember we learned about the octet rule that says all atoms would like to have a full outer shell. Right now, beryllium has 2 valence electrons, or 2 electrons in its outer shell. So it's not really satisfied right now, and it would really like to lose those 2. Remember, if it loses its 2 electrons, it's going to have a configuration that looks like this. It will only have 2 electrons on its first shell, and since it has lost those 2 valence electrons, it now has a charge of positive 2. So we would call this an ion, and specifically because it has a positive charge, we would call it a cation. Now the thing is that electrons can't just appear or disappear out of thin air. They're actually gained and lost when atoms combine to form molecules. Metals tend to lose electrons and nonmetals tend to gain electrons, as you saw with me before the break when we learned about the trends in the periodic table, and we showed how the metals tend to lose and the nonmetals tend to gain. So let me show you an example of how an ionic compound might be formed. Here you see 2 Bohr diagrams. One is for the element sodium and one is for the element chlorine. So let's go ahead and label our 2 diagrams. Now we notice that sodium has 1 valence electron, and sodium is unhappy right now because it really wants a full outer shell, and it would really like to lose this 1. Chlorine, on the other hand, has 1, 2, 3, 4, 5, 6, 7 valence electrons. So hopefully you can see that it would really like to gain 1 electron. Now this appears to be the perfect match because what can actually happen is sodium can give its valence electron to chlorine. So now sodium has lost its electron. It now has a +1 charge since it's lost 1. And chlorine, which has gained an electron, now has a -1 charge for gaining 1 electron. So overall, I have a sodium ion with a +1 charge, and I have a chlorine ion with a -1 charge. The strong positive and negative charges attract together like a magnet. So they're going to stick together and form a compound which we call NaCl. Let's define an ionic compound and an ionic bond. So an ionic compound, it's a compound made of 1 positive metal with 1 negative nonmetal. An ionic bond, it's a simultaneous strong attraction between positive and negative ions. Okay. Let's do one more example together. Here I have aluminum and chlorine. So hopefully you can see that this is my aluminum. And I have actually 3 chlorines, and you'll see why in 1 second. Chlorine, chlorine, chlorine. Now in this case, I notice that aluminum has 1, 2, 3 valence electrons. Now according to the octet rule, it likes to have a full outer shell, and it would really like to lose those 3 electrons so that it can be stable. Chlorine, as we said before, has 1, 2, 3, 4, 5, 6, 7. It would really like to gain 1 electron. So we might do what we did before, starting with aluminum donating 1 electron to the element chlorine. Now this is good for this chlorine atom. It's happy. It now has a full outer shell. But aluminum, is it happy? No, it's still got 2 valence electrons that it would like to lose. So aluminum is actually going to give its next valence electron to another chlorine atom. And you can probably see what will happen to the 3rd valence electron. I'll draw a big arrow now, all the way over here. All right, so aluminum has donated 3 electrons, 1 to each chlorine. I've made another compound, another ionic compound, consisting of 1 aluminum and 3 chlorine atoms. So the ionic compound would be AlCl3, because I needed 3 chlorines to take the 3 extra electrons from aluminum. I'd like you to pause the video here and try questions 1, 2, and 3. This should take about 5 minutes, and when everyone has finished and you've taken up the answers together as a class, then we'll move on to names and formulas of ionic compounds. Okay, so you've done the comprehension check questions. Now we're going to learn how to name ionic compounds. Let's make this straight again. Okay, so when we name, ionic compound names have 2 parts. The first part is the name of the metal. It always starts with the metal. And the second part is the nonmetal. Remember on my periodic table that the metals are all located to the left. There is a staircase here, an imaginary staircase that looks like this. And all the nonmetals are on the right. So the name of the metal ion remains the same as the name of the neutral metal atom, but the ending of the nonmetal changes to "ide." So let's start with NaCl. I start by naming the metal. Na is sodium. And then I have to name the nonmetal, changing the ending to "ide." So this would be chloride. Let's try one more. LiBr. I name the metal. Li is lithium. My nonmetal is bromine, but I changed the ending to "ide, so it would be bromide. Try answering the rest of the questions by yourself. Now let's say we wanted to go in the other direction. I provide you with a chemical name, and I want you to be able to provide the formula. Let's do magnesium oxide. So I'm giving you the name and I want you to write the formula. The key here is to remember that when the positive and negative ions form an ionic compound, the overall charge must be neutral. So I have to constantly be thinking of my Bohr diagrams and the number of valence electrons that they have and the number of electrons they'll want to gain or lose to become neutral. So let me show you. Step 1, write the symbol for each element. So magnesium is Mg, and oxide is oxygen, which is O. Now, in order to write the chemical formula, I first have to determine the charge that each element will have when it becomes an ion. So I have to have a good understanding of the periodic table here and my groups. Magnesium is here. It's in group 2. Do you remember the name of this group? It's the alkaline earth metals. And all of the alkaline earth metals have 2 valence electrons that they would really like to lose. So when they become ions, they all have a charge of +2. So I'm going to write +2 above the symbol Mg for magnesium. Now oxygen is a nonmetal. It's found over here in this group. Now all of the elements in oxygen's group have 6 valence electrons. 6. So they would really like to gain 2 to have a full octet, and if they did, they would have an ionic charge of -2. So I'm going to write -2 on top of the symbol for oxygen, O. Now, when the positive and negative ions form a compound, the overall charge must be neutral. Fortunately, +2 and -2, if I add those together, I get 0, so it's neutral. So that means I only need to have one Mg and one O in my compound. So this would be MgO. Let me show you an example when I might have to do some balancing. Let's do magnesium bromide. So magnesium, we just did. It's an alkaline earth metal with a charge of +2. Bromine, however, is a halogen over here. And all of the halogens in this group have 7 valence electrons. They would like to gain 1, so they have a charge of -1. Bromine, -1. Now this time you can see that 2 and 1, -1, they're not neutral. They don't equal 0. So hopefully you see that if I add 2 bromine ions, each with a charge of -1, then overall my compound will be neutral. Okay, 2 bromines, each with a charge of -1, means the total charge of bromine would be -2, and that balances the +2 charge of magnesium. Therefore, my formula is going to be MgBr2. For every 1 magnesium, I need 2 bromines. There are 1, 2, 3, 4, 5, 10 questions here for you to practice. So I'd like you to take a few minutes now to follow the same steps that I've showed you above and answer these questions. Okay, next we're going to learn about the polyatomic ions. A polyatomic ion is an ion that consists of a stable group of several atoms acting together as a single charged particle. The ionic charge of a polyatomic ion is shared over the entire ion rather than just being on one atom. In grade 9 science, you need to know these polyatomics. OH is hydroxide, SO4 is sulfate, CO3 carbonate, PO4 phosphate, and NO3 nitrate. The charges of these polyatomics are given here. So here's a sample problem. Write the name of the compound Na2CO3. So I notice that this one looks a little bit different because I have 3 elements: sodium, carbon, and oxygen. When I recognize that there's more than 2 elements in my compound, I realize I have a polyatomic ion. So how do I write the name of this? Well, we're going to follow the same steps. Step 1, write the name of the metal, sodium. Step 2, write the name of the polyatomic ion. CO3 is carbonate. Okay, that's it. So this compound is called sodium carbonate. Take a few minutes now to name these 4 compounds in your notes or in your lab book. Okay, now we want to go in the other direction. So I'm providing you with the name, and I'd like you to write the formula. We'll follow the same steps as we did for the simpler ionic compounds, but I've broken it up to show you all the steps here. So to begin, we're going to write the symbol and charge of the metal. Magnesium, we've done that one a couple times now. Magnesium is Mg, and its charge is +2. Write the symbol and charge of the polyatomic. Sulfate is my polyatomic. It's SO4. And the charge of sulfate, looking on my table, there is -2. Step 2, determine how many of each type of atom are needed to make a neutral ionic compound. Well, I notice that +2 and -2 equals 0, so this one's already balanced. So I only need 1 Mg and 1 SO4 to make a neutral compound. So the formula is just MgSO4. If these 2 numbers were different, I would have to follow the same steps that we did over here, where I might add more of one type of atom so that the overall charge is 0. Take a couple minutes to try these 3 questions in your notes. The last type of ionic compound that we can name includes what we call a multivalent ion. So, chemists have discovered that there's 2 stable forms of iron, Fe+2 and Fe+3. These ions are named like other ions, except we use Roman numerals to identify which form of ion is in the compound. So, let's do a sample. Write the chemical name of CuO. Note that copper could either have one of 2 ionic charges. Because it's a multivalent, sometimes copper has a charge of 1, and sometimes copper has a charge of 2. So right now we don't know which charge copper has. So how are we going to name this compound? We'll follow the same steps, but we're going to add a symbol X to represent the unknown charge. Step 1, since you do not know whether the charge on copper is +1 or 2, use X to represent its unknown value. So I'm going to write copper, and I'm going to put an X on top of it because I don't know its charge. Oxygen, however, I do know. On the periodic table, oxygen is in this group, and it has a charge of -2 when it becomes an ion. So, since I know that overall the compound must be neutral, I can reason that the charge on copper must be positive 2. So this is going to be copper, in brackets, 2 oxide. A little aside here, you need to know some Roman numerals next. Number 1 in Roman numerals is 1, like that. 2 is that. 3 lines. And 4, IV. And that's as much as you need to know. I'd like you to practice these ones in your notebook. Now there is one trick question in here. This one. When you do it, see if you can figure out why this one is a trick question. Last sample problem. I've given you the name, and I'm asking you to write the chemical formula. So we're going to start by writing the symbols of each element in my compound. Lead 2 oxide. Lead is Pb, and oxygen, O. I've written the chemical symbol. I need to write the charge of the metal. So Pb, it's actually told me right here what the charge is. It's 2. Oxygen, I know from my periodic table, has a charge of -2. And I notice right away that 2 plus -2 is equal to 0, so this is already balanced, PbO. That would be my formula for this compound. Go ahead and try 2A, B, and C. Grade 9, so that's the end of our note. This will be posted on Moodle, so you can pause and go through and listen a couple times, as many times as it takes. You have a wonderful science teacher in your class today who can help answer all of your questions. And hopefully you'll do some homework tonight. Practice, practice, practice. That's the best way to make this become easier. See you soon. Bye.